Unit 2, Stability Analysis of Slopes. The contents are causes and types of slope failure. Second, stability analysis of infinite slope. Third, stability analysis of finite slopes. Both these methods are applicable for cohesive, frictional and purely frictional soil, that is cohesionless soil. Then methods for analysis of infinite slope, that is Swedish circle method and friction circle method. These methods we will learn, and at the end, what are the methods for improving the stability of slopes. In this way, the contents we are going to cover under Unit 2. So what will be the course outcome or learning outcome of this Unit 2? The learning outcome will be, we will be able to analyze a given slope, whether it is stable or unstable. Alright, let us move on to the introduction part. On your screen you can see there are two images. Image 1 is related to a hill and image 2 is related to a dam which is constructed with the help of soil. In image 1 you can see this is a natural slope which must have continued further, but for the purpose of construction of road, this much portion of soil is removed and this slope is retained with the help of this vertical structure. It is called as retaining structure, and this road is being used for transportation. Now when we cut the soil or take out the portion of soil from this portion of the hill, we are basically disturbing the stability of the hill. Hence we have to analyze whether now this slope is safe, stable or not. Okay, so this kind of slope is called as natural slope. Now second image speaks about an artificial slope. Earthen dam is an artificial slope. This dam is used to retain water. Now it is constructed with the help of granular material. This retaining structure is constructed with the help of soil, right? So this water may percolate through this body of the dam. Alright, hence that water pressure, the seepage pressure, and depending upon the properties of soil, whether this slope is stable or not, that we have to check. It is called as analysis of finite slope. So natural slope, that is hills, it is called as infinite slope, and this earthen dam which we have constructed, it is called as finite slope and artificial slope. Okay, this third image is related to failure of slope. Now here you can see this is a railway track. Okay, it was supported by the ballast. Now this ballast is we can say deposited in the form of a slope. It is a continuous slope or support which is provided below the railway track. Now because of multiple reasons this failure might have happened. What can be the multiple reason for this failure? Cyclic load. Okay, continuous trains are going, so there would be a cyclic effect of the load. Second, heavy rains. So in this way there can be multiple reasons for the failure of any slope. So here the reason may be the cyclic load, or maybe surcharge, or maybe the heavy rains. Okay, hence we have to analyze a particular slope for its worst load combination. For this we have to understand the shear strength of the soil. Okay, so shear strength topic is important. Finding out shear strength parameters, finding out which type of soil is available at a particular site, all those things we should be able to understand. Then we can go for stability analysis. So gist of this we will see now. Natural slopes, valleys, hills, cliffs, these will be included in natural slopes. Artificial slopes will include cuttings and embankments. which are made for roads, railway tracks or canals. Temporary excavations which are done for foundations, like if we go for construction of basement, then we have to dig out the soil, maybe 10 feet, 12 feet, 15 feet. So we have to cut the soil. So that vertical cut itself is a very steep slope. So it is an artificial slope. And waste heaps. So lot many waste or garbage material is deposited in the outskirts of a city. So it will form a heap kind of thing. So that is an artificial slope. Alright. Now this slope is required to be made effective, cost effective, right? And second, safe and stable. It is made cost effective by making it steeper. But steepening of slope includes, or it may cause the failure of slope, collapse of the slope. Like if we cut a soil which is soft soil and we are going for vertical cut, it may collapse. Hence, what should be the slope angle so that it will remain stable? That we have to analyze. So making a slope steeper would be cost effective, but we don't know whether it is stable or not. Hence, a slope should be cost effective as well as safe. Hence, it requires analysis. So this is the need behind the slope stability analysis. Now, what are the basic reasons behind the failure of slopes? So if you categorize multiple reasons under two heads, those two heads would be increase in the shear stress and second is a decrease in the shear strength. How this increase in the shear stress occurs? The reasons which are responsible for increase in the shear stress, those are weight of water at saturation of soil, surcharge load, seepage pressure, steepening of slopes due to excavation. Now, how this shear stress would act in a soil? Basically, shear stress acts tangential to the surface of failure. Okay, so if there is a slope, then the stress which will act parallel to that slope would be called as shear stress. Now, weight of water at saturation of soil. If there is dry soil and now the water content is increased, it has reached its saturation level. What will the effect of this? Any soil which has cohesion or friction or both, it is going to be affected by this saturation. Okay, this water will add additional pressure on the particles of the soil when it will start flowing down the slope. That will cause increase in the tangential or shear stress. Hence, seepage pressure and weight of water at saturation level, these will cause increase in the shear stresses. Another reason which is mentioned is surcharge load. Suppose there is change in the type of utility. Initially it was a residential purpose for which a structure is made. Now it is being used for commercial purpose. So there is change in the occupancy, hence change in the load, increase in the load and increase in the vertical pressure, and vertical pressure would cause increase in the shear stresses. Steepening of the slopes due to excavation. When we have seen the example of a road which is constructed by cutting the hill, so we have to cut that hill at its bottom or maybe somewhere in middle. So it will disturb the lateral support to the hill, and the soil which has been removed, it will create a space, and towards that space the soil will start moving down. Thus there would be increase in the shear stresses. The second heading is related to decrease in the shear strength. How the shear strength is decreased? As I told you before, shear strength is governed by two important parameters. One is cohesion and second is angle of internal friction. So when there is increase in the water content, it will cause increase in the pore water pressure. What will happen? Because of this increase in the quantity of water, the water will try to make two particles separate. Okay, so there would be repelling forces acting between these two particles which were otherwise together due to cohesive nature of the soil. Now they are getting separated. At the same time, this water will lubricate the friction between the particles at the point of contact. Thus cohesion and frictional resistance both will be affected because of increase in the water pressure. Next reason which is mentioned is cyclic load. When a particular value of load acts on a soil strata for n number of times, then due to this cyclic nature of the force, there would be disturbance in the soil structure, and that disturbance in the soil structure would affect the shear strength of the soil. Another reason is earthquake load. Because of earthquake also there would be change in the position or structure of the soil. If water is present, it will exert some extra pressure on the particles. Okay, so in this way there would be decrease in the shear strength of the soil. Thus, from this slide what we have understood, there are only two important causes for failure of slope. One is increase in the shear stress and second is decrease in the shear strength. And under these two heads there are multiple reasons which help these two things to happen. Alright, so I hope you have understood these two factors, that is increase in the shear stress and decrease in the shear strength, which are responsible for the failure of the slope. In next lecture we will see what are the basic assumptions which we make for the analysis of slope. Thank you.